universal bridge, it's very simple, ma'am. Definitely, it should be there in the MATLAB. So let me. Okay, right, no issue. I will teach you now. So we'll check. Yeah. So open the new block. Just search universal bridge. Yes, this is a universal bridge. So like that, in your MATLAB also, it should be there. Okay. Okay. So let us complete the session. We'll move to the next one. Yeah. So as per our schedule today, we have to discuss about motor control for the EV applications, right? So, yeah. So let us check. So today we will discuss in detail about what is the motor types and how the motor parameter can be. I mean, it can be understandable for selecting the appropriate loads. And finally, we'll check. We'll verify the DC motor speed control block sets. Nice. See, now, if you know what is the electric motor, so the electric motors are used to convert electrical energy into that mechanical energy. So, mechanical energy only, like actually, as per our earlier discussion, see the 10, this is that 10 kilowatt, and finally we'll get 8.5 kilowatt, right? So, this 8.5 kilowatt only going to apply on the vehicle structure, right? So this is what we have discussed in the previous session. So if you, I mean, how you can select the proper motor for your EV application? How you can select the proper motor for the EV application? In this case, first any motor. So irrespective of motor type, the motor should have a high efficiency, high instant torque. Then only see, because we are going to apply this motor in the non-linear segment. Like our application is I mean non-linear segment, the EV application. So the instant power delivery should be high, and then fast torque responses, high power density, like the size should be very less, and then torque should be high, and low cost. Of course, cost plays a major role, and high acceleration, that is that moment should be high, and then robustness. Robustness nothing but like we are going to use the motor in the EV. So the EV, the electric vehicle should I mean what should pass all the test scenarios, like say actually around the year. So we I mean, as per that geographical location, we may get 4 different seasons. So high temperature season, high low temperature season, and then high dust season, and then high wind season. So all the seasons should pass. And the vehicle should not get affected, right? And then on the IPC standards. So what are all the IPC? I mean, what are all the standards? Other standards like vibration, and then I mean what? Any shock. So all those stuff, the motor should have capability to handle all the disturbances. So now, how we can understand the motor performance? See here. So if you take a torque versus speed curve, so up to critical speed, so that is the rated speed or critical speed, the torque you can operate a motor with the low speed torque as well as the high speed torque. See here, if you take this scenario, see here during this period, the torque is high and then speed is low. Whereas here, torque is high and then speed also high. So now in the IC, in the electrical engine, you can operate, you can control the motors in both the cases, right? Whereas in the IC engine, it's not like that. Either if you want to increase the torque, you should reduce the speed. If you want to I mean what reduce the torque, then you should, yeah, if you increase the speed, then only, I mean, at that time the torque will get reduced. So like that moment only will happen in the IC engine, but in the electrical engine it's not like that. So we can independently we can control it. And so if you take I mean types of the motors, so electric motors, I mean what classified into 2 types. One is a commutator motor and then commutatorless motor. So under the commutator, self-excited motor, separately excited motor, and these are all the DC motors, right? So this is comes under the DC motor. The commutatorless motors comes under the AC motors like a synchronous, asynchronous motor. Under the synchronous motor, wound rotor, permanent magnet rotor motor, and then reluctance motor. Similarly, all the type of motors available in the market. So now, what are all the our motor? We will select the motor. So we have a different type of motor, like a reluctance motor. We will use like under that one, the switch reluctance motor, permanent magnet brushless DC motor, and then hybrid motors. So squirrel cage induction motors. So these are all the motors used in the EV applications. See here, the hybrid motors, nothing under this one. Will use that synchronous reluctance motors and then permanent magnet synchronous motors. So all the motors will be used. So now, if you take what do you mean by commutator motors? So commutator motor nothing but in the edge. So you will get a brushes. The brushes will try to convert the volt. With the help of the brush and then contact, the alternate voltage will fed into the coil. So due to that, we are getting that magnetic repulsion inside the motor, armature. Due to that action, we are getting the movement, right? Similar way, the same process can be controlled with the electronic circuits also, right? So because now the due to advancement in the semiconductor technology, so we are getting a high frequency solid state switches like a MOSFETs or IGBT. So that will do the same work, but it will be electronically. There is no any friction issues. There is no any noise issues. So automatically the MOSFET will comes into the picture, right? So now, similarly, if you take what are the types of motor in the for the electric vehicle, synchronous motors comes under the AC motors, right? So again, in the synchronous motors, AC motor, there are asynchronous as well as the induction machines. So in that area, in the AC motors, so there will be mutual induction principle. Whereas in the DC motors, only that alternatively we will generate voltage with the help of either electronic circuit or else the mechanical contact. Whereas here, due to the getting what rotations. So now, okay, so apart from the type, if you talk about motor, so what will be the participants? Can you see my screen?
Yes, sir.
If someone has mentioned screen not sharing. Okay, okay. So you people are seeing my screen, right? Got it. See, apart from the motor types, so if you purchase any motor, first these three parameters needs to be understand in deep manner. Like motor power. So what is the type? What is the power rating of the motor, and then how the torque can be calculated, and then what is the maximum speed of the motor, right? Or else the critical speed. So now, if you take this, what a video. So the three factors that determine the type. Yeah. See here, the motor going to rotate, and so this movement is called the speed, right? The movement of the shaft. It will rotate with respect to the reference frame. Then we can call it as a speed. So now the torque, how that torque can be controlled, without reducing the speed. The load needs to be operated like a pull up, and the work needs to be completed, right? So that is the torque. At the same time, the speed should be as per the rated value. Then only we can we can get a proper motor for our exact load condition. So here the speed and torque needs to be performed in the vehicle. Then only our vehicle travel will be very smooth. Otherwise, what will happen? Like a unequilibrium state will exist while the vehicle in the running conditions, right? So you please try to understand these three parameters, then only you can select the motor. So now let us show you some value in the demo. See, just go to the Simulink. You know that, yeah. So just to take a DC machine, see here, the people are telling that the preset model like 5 HP 240 voltage, 1750 RPM, and then field is 300 voltage, right? So this is the typical rating of the motor. So now let us try to understand that
Sir, screen not
hello.
sharing, sir.
Yeah, screen sharing, man.
It's visible, sir.
It is sharing, sir. Anybody, any others? Just give me a sign. I think due to my network, it's agree. Yeah, see, actually, my net, I think, very lag. That's why. So let me off my camera so that you may get stabilized screen. Yeah. So now, see, the P is equal to 2 pi n divided by t. Right. This is the formula. Yeah, yeah. So this is the typical formula. So now we know that P is equal to in our simulation, P is equal to power is equal to 5 HP. So first we have to convert the 5 HP into kilowatt. How we can convert that 5 HP into kilowatt? So kilowatt P is equal to 5 into 7, like around 786, right? So this is the 3.9 kilowatt, right? So here you should, speed is about, it is 1750 RPM. And now, can you calculate the torque? Sorry, the formula is that 2 pi nt P is equal to 2 pi nt divided by 60. Formula is that 2 pi nt 2 pi nt divided by 60. Right. So the P is equal to. So the P is now the 3.9, 3,900 and equal to 2 pi n 1750 and T divided by 60, right? So so now you just convert the everything and then calculate the T value and share the T value in the chat box. So it will be approximately how much it will be. Can you please calculate the value? Participants, can you please calculate the value? What is the T value? T is equal to what? T is equal to what? 3,900 into 60 divided by 2 pi n. That 1750. So apply the value. So it will be approximately 20, approximately. So just to do the calculation and share the output, share the value in the chat box. So now I will demonstrate you like how the torque can be managed. Other preset data, 5 HP, 240 voltage, 1750 field 300 voltage, right? So take a DC voltage source. So armature and then field. So field is about 300. So apply the value. Field is 300 and armature 240. So interconnect everything. Yes, take a bus selector. So remove the component speed and then take a torque value. Select and then apply. And take a power guide block. Take a power guide and so now let us apply the load to the motor. See here. Oh my God, sorry. Sorry, participants. Sorry, actually that keep on the call coming. So let me switch off the phone. Yes. So now, so here, what we have to do. So please share the torque value, total torque value. So approximately 20.5 will be the torque value. So up to full load. This is the 20 is the full load. So now let us try to run this one without below the full load value. Yeah, just take one simulation time. Oh, sorry, have to connect the scope block. So see here, yeah. So here we have to convert speed into RPM. So take a gain block, convert 30 by 8. So this is the radian per second to RPM conversion. Yeah. See here, approximately above 2000. So actually, that value of the rated rated load, rated speed is that 1750. So now almost very less load. So that's why the speed is more than critical speed. So now let us apply a 20. This is the full load value. So in that case, approximately 1750 is the rated current, rated speed, right? So till that the torque will be completely extracted. Suppose what will happen if more than the torque is applied? So let us assume that 30 Newton meter. So what will happen? The critical speed has been reduced. But the actual motor speed is that what? 1750 RPM is the actual critical motor speed. But here the motor speed has been reduced due to that load. I mean, motor has been loaded more than the critical load, right? Is it clear, participants? So this is what we have to operate within the critical range. Within the critical range, we have to operate the motor in very safe manner, right? If you have any questions, please ask so that we'll give you the answer. Yeah, if you have any questions, please ask me. I will give you the solution. So similar way, so let us try to understand. This is the very first parameters. First, you should know the torque and then speed and then power of the motor. So now, I mean, motor applications in the EV. So wherever, I mean, what inside the EV, what are all the motor applications? We are going to use the I mean, motor for the sunroof, I mean, open and close, and then sliding door, and then I mean, four-wheel drive power transfer case, and then seat adjustment, front wiper, and then HVAC system like I mean, cooling system. What is indicated by the constant value? So here the constant value nothing but, see, this is the constant value. This is nothing but it's a torque load. We are connecting the, we are I mean, what we are loading the motor with the torque Newton meter. Yes, and these are all the motor applications which is required by the EV, right? So for these applications, we can use either DC motor or BLDC motor, right? We can use a DC motor or BLDC motor. Whereas the main powertrain motor, so for this one, you can use a BLDC motor, PMSM motor, interior permanent synchronous motor, or switch electrons motors, right? So here and all you can use like that. Now, I mean, DC motor is not suitable for the electric vehicle application because there will be a huge, I mean, what? So you cannot meet out that IP standards with the DC motor. So, but EV applications, it may require exact IP standards. That is what water resistant, right? So I mean, rest of the motors can be used for the EV applications. Now, one by one. So let us try to understand the I mean, DC motor working principle. Whereas in our EV design master class, we have discussed DC motor, induction motor, PLDC motor, PMSM motors, SR motor. So all 5 motors has been discussed and detailed design, and then the implementation part has been given. Suppose if you are more interested to know about all the motor control principle, you can check our I mean, what our coordinator, they will help you to get access such kind of courses. Yes, yes. Yeah, someone has asked that EV, sir, EV inner wheel or outer wheel drive, which is best? See, for the two-wheeler, the hub motors has been used. So the outer rotor motor will be the better one, right? Outer rotor motor will be the better one for the two-wheelers application. The same for the, I mean, in-wheel motor car type of applications, that is, I mean, same outer rotor motor with I mean, that is not a hub motor, it's a in-wheel motor. So the DC motor, these are the type of motors available in the market from small range to higher range. So see here, this, I mean, this is the very low voltage, and this will be the higher voltage. So from this one, you can easily understand when you try to increase the terminal voltage, the size of the motor will get increased, right? Yes. And you know, so these are all the very basic informations like how the I mean, what DC motor working principle. So let us skip that one. See types of the DC motor. So like I mean, basic series separately, shunt mount, compounder motors and that. So now, how the speed control can be achieved. So either flex motor or armature rheostat motor. So finally, with the voltage control, with the help of power solid state switches, we can implement the voltage control method. So how can be controlled the voltage control, right? See here, first we should develop a Hutch bridge circuit, right? So in that one, motor should rotate motor will rotate when you try to apply the PWM. When you apply a PWM for the switch 1 and then switch 2, you will get a positive I mean, one side clockwise direction, I mean, one side movement rotation. Same way, if you change the PWM for that S2 and then S3, then you may get opposite direction, right? So by repeating the similar method, then you can get a forward motoring as well as the reverse motoring. So shall we implement the control logic into the MATLAB Simulink? Participant, shall we implement the control logic into the MATLAB Simulink? If you are ready with MATLAB installed laptop, then just comment in the comment box. We'll give you the solutions. We'll start the modeling. Yes, thank you, madam. So now I'm going to open the MATLAB. See here, field, we can keep it fixed. So just keep it. Yeah. So now first we should, there are different type of methods, like even with the single switch also, the speed control mechanism will be implemented. So now we can develop a H bridge controller. So take a MOSFET, and yes, so this is that D1 or device 1. So just minimizing the sizes so that we can see in very big manner. So now, so this is that, so D2, and then take a two more copy, then you may get a D3 and D. So interconnect all the devices, So now remove this connection. Form as a H bridge. So in center we have to connect a armature, right? Is it clear? Yeah. So now we may require the PWM signals. So to generate a PWM, first we should take a ramp, repeative sequence, repeat. So here, see, we may require the PWM controller, right? So how the PWM can be controlled? We may require two signals. This is the reference signal. So either like this, we can construct, or else we can construct. So this is the unipolar PWM control method. Same way, we can go for the bipolar bipolar PWM control method also, it is possible. So now let us try one by one. Any one of the method you can select, and so here the switching frequency will comes into the picture, and at the same time how this can be modeled. So now I am trying to build positive triangular, right? So like that, and average, if you compare the average, then you may get a PWM, right? You may get a PWM, so that can be applied here. So how this can be controlled, and then how it can be applied in the sense, let me take time value. See here, 0, 0.5, and then 1. This is the 3 interval part, and then switching frequency, like 5,000 is the switching frequency, and here 0, 1, 0. So if you apply here, then you may get a proper sine waveform, triangular waveform, and you may require a reference value, right? So take a constant 1 to keep load as very limited, like 15. Yeah. See, so the reference is that 0.5 is the that is the minimum one. So the motor control will operate one direction within this range, like a triangular. This is the triangular. So we take, this is the 0.5. So 0.5 will be the exactly equal voltage. So at that time the machine will not support. So within this range, like 0 to 0.5, and then 0.5 to 1. So during this region, the motor will rotate in one direction, and during this region, the motor will rotate in the another direction, right? Another direction. So now let us develop a block and take a comparator. So like a relational operator. So either anything you can connect. So now we may get one PWM, right? So that PWM you can apply for the diagonal switches. The same PWM should apply for the diagonal switches, right? And the inverted PWM, take a NOT gate, apply to the, yes. So this is the, So this is the PWM generation for the DC motor, okay? So now you can vary this value. So like 0.02, and 0 to 1, you can vary anything. So by the time the motor speed will get up, verify. Is it clear, participant? If you have any questions, please ask me. Please don't be as a silent. If you ask any, if you have any questions, please ask. Then only I can understand. Okay, you are following the things. So simple DC motor control. So now I'm just trying to run this one. So let us keep 0. Yeah, the speed is about positive. Same way, if you go more than 0.7, speed will be in the reverse direction, right? If you continuously operate, what we can in between we may apply a brake mechanisms also, right? This is very simple PWM control. Similar one, we can apply a brake mechanism also. So let me open now. Participant, can you see the difference? So this is the reverse motoring and this is the forward motoring. So here I have applied the forward motoring, and same way here we are applying 0.75 the reverse motor. Can you understand the principle? How the PWM is changing the motor direction. If you have any questions, please ask. Let me give you the solution. Yes. Can you compare the Simulink model with the block diagram so that becomes more clear? Yes, Amrita ma'am, I'm not understanding your question. Can you compare the Simulink model with the block diagram? Which block diagram do you are telling? Just open the mic and tell me so that others also get clarified. Amrita? Okay, ma'am. Amrita ma'am, can you just open the mic and then please tell me? I'm not getting your point. Okay, okay. Thank you, ma'am. So then, if you have any questions, please ask me. Give me a clear question. So now I'm.
Sir, the comparator which you have used, from where you have got that? I'm not getting that.
Oh, no, ma'am. Just select repeat. Relational operator.
Relational operator.
Yeah, yeah, yeah. So just take the first block. That's
Okay, sir.
yeah. Thank
Shall I have to do any changes over here?
Nothing. See here. This is some relational. Either the
Yeah.
this is the first signal and this is the second signal. The logic
Sir, the first signal, what you have taken, sir? First signal.
is that repeat. It's a carrier signal as a triangular waveform. So how the triangular waveform can be modeled with the help of that repeating sequence block. So take a repeating sequence block. Right. So here I modeled like this. This is the triangular one. Right. So the period is the period is frequency is 5005 kilohertz. Okay. And this is zero,
Okay, sir.
and this is the exactly half of the instant, like a 0.5, and this is the one. Then one cycle, right? So
Okay, good evening, sir. This side, Dr. Amrita. I have
uh,
a little bit, it's small query.
yeah, tell me,
Actually, am I?
ma'am, please.
Okay, so if you compare the Simulink model with a block diagram, might be, let's assume I will going to design an inverter. Okay, so I will draw a block diagram that this is the DC input and those are the switches. Then after it's a load. Okay, the same thing I just want to know because you are start a model, Simulink model. So it is better draw the block diagram. So it might be easy for me to understand ke, which one is the EV side, which one is the machine side. Where as you mentioned the inverted, inverted, I think in switches, I think mentioned
Mm.
the word. I'm not getting that point where I just wanted to ask that moment, but due to unable to access my microphone, that's why. Okay, so if you design the block diagram, that means this is the input side, those are the switches here placed, and this is the motor, and this is the part of the EV, so that it can be easy for me.
See here, today we try to understand the motor control technology.
Okay, fine, sir.
Right, the motor control technology. So motor speed is you are going to connect to the vehicle wheel. Okay. So
Okay, fine. But that means you have not mentioned design the EV now. We just discuss about the part of the EVs.
yeah, part we should know no that see actually in the EV, final EV block, so all
Hmm.
integrated, all the components will available as a single blocks. Now, inside the block, you should know what is happening inside, right? How exactly the
Okay,
motor can be controlled.
fine.
Okay, so
Oh, okay, okay, sir.
we are trying to explore, yeah, discuss in detail. So
Fine, fine.
next time you should be very clear about, okay, this is the PWM generating method. So this is
Yeah.
how the PWM going to change. Due to this change, motor going to get a controlled output voltage. So like that, you should be very clear before developing the EV.
Okay, sir, are you using the final block diagram which is mentioned in the Simulink model, or you will design the proper EV model?
Proper EV model we are going to design, madam.
Okay, okay. Thank you, sir. No issue.
So actually now you can easily understand how the speed can be varied. the direction can be varied, right?
Okay, okay, sir. Okay. Thank you, sir.
The control, see, if you go to any Google, right? I will tell you, if you go and purchase the motor, EV motor control. See, this is the simple motor controller. Okay. So here, what you will provide from the pedal input, that is the accelerator and the decelerator. Okay. So when you try to apply accelerator, small 5 voltage will fed into this block. So inside the block, such kind of controlling mechanism will be placed. I hope you got my point.
Yes, sir. No, sir.
Yeah,
I
yeah,
got it.
yeah. That's why we are trying to understand now. And so now we model like how the motor can be forward direction as well as the reverse direction. Similar way, as I mentioned earlier, so the controller part has a reference voltage. You can vary 0 to zero point 0.5 is the one direction, and then 0.5 to 1 is the another direction. So within this zero speed, maximum speed. Same way, this is zero speed and then maximum speed. So like that we can vary, right? So now let's move to the EV. Let's move to the EV block. Before into that, I will tell you one more. I will show you one more experiment in the same principle. Give me a second.
Sir, screen is not shared.
It's shared already. It is in the shared mode only. Yeah.
Okay, might be due to some network issue at
Yeah.
my side. Thank you.
Let's check. So now I will show you one more with control. Just give me a second. I will show you the detailed. See here the same. So now the same motor control part, and here we are generating. So this is the simplified control algorithm, and here I am trying to apply a brakes for some time, motor for some time, and the speed. Now the reference speed is the negative speed, and then armature voltage. Motor is in the reverse direction, right? So now I am trying to apply a brake now because we may require a complete braking mechanisms, right? So just apply a brake. See the motor approach to zero to minus 100 to zero. So now I'm going to apply a a plus 100, and for that we have to release the one. From brake to motoring. Yes. See here the motor has been the motor switched from zero state to the positive forward direction. So like this, we can build the any kind of control mechanism for the motor, right? And this again in the MATLAB will enable you the same logic can be downloaded. So this logic can be downloaded to your hardware. So that is called hardware in loop. So only thing you have to modify the input. You have to configure input parameter as well as that output parameter, right? So like that we can model it. So now let's come to the our first day example. Now let's come to the first day example. Have you completed the first one example? Yeah. Now what I have to do? So here take a DC machine, DC motor, right? Yeah. So let us check on new one and take a like a DC voltage. Excuse me. Now take a mechanical rotational and rotational sensor. Yeah, ideal rotational motion sensor. So just connect here, and then this needs to be that is the no load circuit connection, and this is the W on the A is the velocity and then angle. So W is the velocity. So now take a PS to Simulink converter and connect, take a scope, right? So take a solver configuration because here the Hutch bridge circuit and all little bit tough. So for understanding the purpose only, I built the proper Hutch bridge PWM control in the Simulink model, some power system block, and take electrical reference and take permanent magnet rated load and then speed, like 2000 no load speed, and then 1500 is the rated speed, and 3 kilowatt, and then 100 voltage. So we can modulate whatever, and here the 100 voltage. Apply a 100 volt, right? See here the motor speed is approaching. So now what we have to do? So the same thing needs to be copied and So here, yes, just to copy and connect to the next simulation. I mean, our basic simulation, day one simulation, right? So just remove this one and take a simple gear. Yeah, take a simple gear. I mean, ideal speed information. I mean, ideal speed transfer, and then connect to the angular one. So now what happened? We built the model vehicle free body diagram. So this free body diagram has been connected to the motor load, right? So now we have to build the motor control part. How can we control the motor? So that is the, what? So this logic, as per the previous example, we have to build it, right? Is it clear? Participants, is it clear? If you have any questions, please ask. Let me give you the solution. So I will share you one by one. So please practice this too. First to practice this too. So I will share you this one in the link. Yeah. So I'm just sharing the screen. I mean, just sharing the information. Please download and then please practice all the components, all the experiments, right? So just try this experiment and later you can try that Simulink. So this is very simplest form. You can build your own and the repeating sequence value will be like this. Please practice and then see. Actually, no one is asking. Doubt in the group. Please ask the doubt in the group. I'm here to help you. And the torque, and then here on the 100 voltage. Sorry, on the as per the rated voltage we applied. And rest no need to do anything. And this is the NOT gate, and then some. This is a repeating relational operator, and then repeating sequence. That's it. That's it. Practice this experiment and come up with the tomorrow session. If you have any questions, please ask. Then we will give you the solution. DC motor settings. See here, this is the simple DC motor. I will share. Yeah, please practice this experiment. Come up with the tomorrow class. Tomorrow we will discuss about the battery block. So how the battery can be integrated, all the stuff. Is it clear, participants? Is it clear? Is the information is enough? Please tell me, is this information enough? If you have any questions, please ask. And this is that radian per second to RPM conversion. Battery settings tomorrow I will give. Tomorrow we will discuss in detail about the battery blocks. So here this is not a battery. This is like a DC voltage, small DC voltage. Okay, I will share. Please, participant, please practice on daily basis.
Excuse me, sir. Sir, in that compare 30 by pi, we have to write over there.
Yes, madam. So this is like a simple here.
That is a gain. That is a gain block, no, sir.
This is the gain block. Yes, correct. It's simple like.
Yes, sir. In that we have to mention that 30 by 5.
Correct. Exactly. So here the value will be radian per second. Here this value will be RPM.
Sir, and that scope, how will do that two input scope? Means normally in the scope one input is given, no, sir. How will do that to two input?
See this one. Now I'm just going to take this one. Similar way, just drag and then connect. Automatically it will come. Is it
will
okay?
automatically be good.
Yeah.
Yes, sir. I got it.
Yes, ma'am. Just to practice this experiment, and tomorrow we'll integrate the build block without this. And component selection. Yeah. See here, just to open the block, DC motor component. Select the preset model, any one of the block. Yes. Any doubt, ma'am? Any other doubt? So will you practice this experiment? Will you practice this experiment and come up with the tomorrow class? Yes, ma'am. Thank you, ma'am. And so thank you for your valuable time. So I'm just going to wind the session. And please practice this session, practice this experiment, and come up with the tomorrow class with your all the results. Please don't be ideal, and just try.
Sir, last question, sir. Sir, that repeating sequence and 0.75 that is fed to a comparator. After that, that triangle, what is that, sir?
This is the NOT gate, ma'am. Inverted pulse. This is NOT gate, inverted pulse. See the compared output for the D1 and then D4. Okay, that is the pair. Inverted pulse for the D2 and then D3. Is it clear? Participants, is it clear? If you have any questions, please ask. Highlight the components. Okay. Just to take a snapshot. So unwanted things, we can remove it. Now I think so you may get clear, right? So let me share something. Yeah. So I have shared all the screen. Please practice, just implement this one so that you can get involved in the Simulink. It's very easy design. It's a model-based design, and complete the assignment. for the tomorrow class.